Hello everybody, and now I want to explain about the star clusters. Let me share my screen. Yeah. Evolution of star clusters. Star clusters form with the following characteristics. First, total mass or and initial mass function or IMF, metallicity, kinematics of the cluster center, location within the galaxy, internal velocity dispersion, and how does the star clusters evolve with these starting parameters? Each member or star evolve as an individual. Some important topics. First, binary evolution. Second, mass loss or hot stars. Third, AGV or asymptotic giant branch evolution. Fourth, planetary nebula, cool stars. And fifth is supernova explosions. In star clusters, collisions are very uncommon. See later, as I will tell you later, almost no new multiple or binary systems form during the later evolution. And star clusters normally follow galactic rotation. In here you see the different evolution of stars. If there is a protostar and it has a massive giant molecular clouds, you see a blue giant blue supergiant, and then blue supernova, and then supernova, and we have different kinds of supernova. And here, for example, it is our sun life with this protostar giant molecular cloud, and we have our sun or sun-like star, and then it will be a red giant, and then planetary nebula, and then white dwarf. And we can say if we have less magnetic field, there are more star cluster cores. For forming the stars, first we need turbulence, shock waves, rotation, fragmentations, and then second we need magnetic field because the magnetic field is very weak. In supernova explosion in binary stars, the companion and open cluster survive. If there are several supernova explosions in one open cluster, the stars pull out of the open cluster because the gravitation won't be enough to keep the stars. And the energy that is transported by shock wave is very small compared to the mass of the stars. The shock wave is not much energetic to destroy the open clusters because the explosion of the shell of the supernova explodes in 3 dimensions or 3D. Its energy drops in around 1 month or 1 year, which is very fast. And there are supernovas just in open clusters because supernova is from massive stars, O and B type stars, which they are just in open clusters, that they are young and have O and B type stars, but not globular clusters, which they are old and do not have O and B type stars. We can say still there is no any hint related to find a black hole in open and globular clusters. The question is, why do star clusters dissipate? Maybe collisions. If we want to have some surveys about the collisions, we can say we can use real theorem and kinematic energy, and then you see the potential energy and yielding. And with some calculation at last, we can say that collisions play no role in dissipating the star clusters. Even in the most inner core parts, collisions are highly improper, but could occur. And the conclusions are binary and multiple systems are not results of collisions in later stages, but form already at the very beginning. And second is members do, in general, not escape due to collisions, swing by effect, but the peculiar velocity component is part of the cluster formation or due to supernovas. The other answer maybe is crossing timescaping or internal velocity dispersion. And you see this crossing time, members can escape from a star cluster on a relatively short time scale. And the reason is velocity dispersion caused by the cluster formation and supernova events. The other effect is differential galactic rotation. Total mass of the Milky Way, as you see, and the gravitational acceleration of the complete star clusters or G open clusters, and the individual members, G star, and RGC is distance of the star cluster center to the galactic center. And R, this small r, is distance from a star to the star cluster center. The difference of these two values is the force of which the Milky Way tries to pull away a star from the cluster. On the other side, we have the gravitational force of the star cluster. The stability radius RS is defined as this. This is if there is a stable or stability between these two. The gravitational acceleration of the complete star clusters, GOCL, and the individual member, G star. If there is a stable here, we call it stability radius. At last, we can say, again, ask you why do star clusters dissipate? We can answer first differential galactic rotation, which means moving the star clusters around center of galaxy is important in dissipating of star clusters. Then internal velocity dispersion or crossing time escaping, which means when during the time stars are move and become far from the center of the star clusters, the effect of the gravitation of the center of the cluster to them become less and they dissipate the star clusters. And then we can say collisions in the first few million years, or we can say after a star cluster formed and after they are stable, collisions play no significant role in dissipating star clusters. But after star clusters formed, no binary forms, but collisions are important in the first few million years. And then we can say supernova explosions and corresponding shock waves. And we can say for this, the other one is collisions with field stars or explanations of the existence of globular clusters and valid for all spiral galaxies. Thank you for your attention and see you next time. Bye.